Hello. Today we're going to go through maximum depth of binary tree, which is LeetCode problem 104. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So if we look at example 1 here, we start with the root node, and we go to the left, we only have one node. But we go to the right, we have 1 and 2, either by taking the 15 or the 7. So the output is 3, 1, 2, 3. And actually, to read this initial tree, we have 3, 9, 20, and the two nulls signify that there's no left or right branch on the 9, and the 15 and the 7 are the left or right branch of the 20. In example 2, root of 1, no left branch, and a 2 on the right branch, so the output will be 2, the root node and the right branch. 3 is nothing, so the output will be 0, and then 4 is just a root value of 0, so the output will be 1. Alright, so let's take a very simple binary tree, and we'll start with the root here. And what we're going to do is we're going to check the left side first, the left branch. So we'll take the 3, and then we'll check its left branch, which will bring back the 2, and then we'll check its left branch. It doesn't have one, so then we'll check the right branch. It doesn't have one. Then it'll bubble back up to the 3. And we're finished with the left side of the 3, so now we're going to check the right side, which grabs the 1. We'll check the left and right of the 1, which will be null, and we'll bubble back up to the 3. And so on and so forth. This goes back up to the 5, and then we need to check the right as well. So let's see how to code this. So we're going to pass in the root node of the binary tree. So if the root is null, we're going to return 0. And this serves two purposes. One, if the whole tree is null, then it returns 0. But also, because we're going to use recursion to figure this out, eventually you need to return, you need to have the root equal null and return 0 to break out of the recursion. Okay, so we're going to start with the root node, and then we're going to check its left node by assigning the root left and calling max depth again. Now this will keep going because the 2 is also the next left node, but the 2 doesn't have a left node, so then the root left of the 2 will be null, and then that will return 0. So then we need, once we're out of left nodes, then we need to check the right node. So we'll check the right node here, that will be 0, and then, so then we're going to take the max of the left and the right and add 1 for itself, so the 2 itself. So because this is 0 for both the left and the right, the 2 is just going to return 1. And we'll do the same thing with the 3. So the 3, the value of left is 1, and the value of right will end up being 1. And so then left plus right plus 1 will be 2, and so on and so forth. And the debugger should explain this in better detail. But that's pretty much it. So let's see how to debug this. Alright, so I did a very simple tree, and I did this because recursion can get lengthy if you have too many nodes. So I have the root node is 1, I have a left branch of 2, and then another left branch under the 2 of 4, and then just one right branch of 3. So the answer should be 3, the 1, the 2, and the 4. So let's go into this. So now we're dealing with the root node of 1. So we're going to check the left value, which this is going to be the 2. And so now we're in the 2, and we check the left here, which will be 4. And so then we check the left of 4, which is null. So now we go, so that's null. So now we check the right. The right of 4 will also be null. And so now we're going to bubble back up to the 2. So we'll return 0 for left, 0 for right, and then 1 for the 4. So it'll just be itself. So now we're back to the 2. We finished with the left side. Now we're going to check the right side, which it doesn't have anything, so that will return 0. So now it's going to take the left, which is 1 from the 4, and the right of 0, and add 1 for itself. And so this will bubble back to the 1. Now the 1 is taking care of the entire left side. Now we've got to do the right side. And the 3 doesn't have a left, so that will return null. And then the 3 doesn't have a right, so that will return null. So we have 0, 0, and just 1 for the 3. So now we're at the 1. And the 1 has a left of 2 and a right of 1. So it's going to take the left value, which is the max, and add 1. And so then we get the 3. So let's run this through LeetCode and see what we get. So using that first example, output 3, expected 3, and then we'll submit this. All right, faster than 17. Now, I love doing this. We do it again, and we're at 100%. So this I need some to work on this, or it's my internet connection. Who knows? Anyway, so last thing we'll check is the time and space complexity. So time complexity is O of n, where n is the number of nodes. The more nodes you have, the longer it's going to take to traverse them. Space complexity, same thing. The more nodes you have, the more space it's going to take. And that is it. So let me know how I did. If you have any questions, please leave them in the comments, and we'll see you next time.